This is Pre-Calculus Section 2.6 Notes, Part 2. We're going to be finishing off our Section 2.6 by doing another application problem. And before we begin, I wanted to let you know that there is a homework problem in your bookwork set that goes along with this section that mirrors this problem. So you can use the setup that we're about to go through for this problem in your notes to help you set up the example problem in your homework. A hockey team is in an arena with a seating for 15,000 spectators. With the ticket price set at $14, average daily attendance at recent games has been 9,500. A survey indicates that for each dollar the ticket price is lowered, the average attendance increases by 1,000. Find a function that models the revenue in terms of the ticket price. Well, first of all, we need to think about what revenue means. In this case, the ticket price here, we're going to let X represent the ticket price because that's what we're trying to figure out. So that's going to be our variable in this problem. X is going to represent the price of the hockey tickets. And our revenue, obviously, is going to come from whatever our ticket price is, times the number of tickets sold. Or in this problem, we could call it the attendance at the games. The current ticket price, they told us, is $14. So we're going to let our new ticket price, we already said, be X, okay? So the number of decreases in the ticket price would be equal to our current price, $14, minus our new price, which is X. And also, this is going to be the number of increases in attendance. So our change in attendance then is going to be equal to 1,000, because they told us in the problem that for every dollar the price is lowered, the average attendance increases by 1,000. So our change in attendance is going to be equal to 1,000 times the number of decreases in the ticket price, which is our $14 minus X. So then our new attendance is going to be equal to our old attendance, which was 9,500, plus our change in attendance, which is the 1,000 times 14 minus X. And if we were to distribute that 1,000, we would have 9,500 plus 14,000 minus 1,000X. And if we combine like terms, we would get 23,000 minus 1,000X. So then our revenue is going to be our new price times our new attendance. Our new ticket price is going to be X. And our new attendance we just solved for right here is going to be 23,000. Whoops, I'm sorry, I have a little error here. This is 23,500. I apologize. 23,500 minus 1,000X. And if I distribute that X, then our revenue function is going to be equal to negative 1,000 X squared plus 23,500X. So there's our function. Whew, took us quite a bit of work to get there. But now that we've gotten there, we can use it to answer our questions. Part B says, what ticket price is so high that no revenue is generated? Okay, well, remember, no revenue would mean that our revenue function is equal to 0. So if we set our revenue function equal to 0 and we solve for X, we would have 0 equals negative 1,000x squared plus 23,500x. And if we were to factor out a GCF, we could take out a GCF of negative 100x. Then what we would have left would be 10x minus 235. So now by the zero product property, we can just solve these. And so this one, negative 100x equals 0. Obviously, that tells us that x equals 0. And that should make sense, right? That if we charge $0, we're going to be making 0 revenue. But the other function is the one that's of more interest. If we solve this one, if we let 10x minus 235 equals 0, and we solve for x, we get x equals $23.50. Okay, so basically that's the price and I apologize, I did the math on the previous page here. So basically we just solved for this and we found out that x equals $23.50 is the charge per ticket where no revenue would be generated. That's just too much money and nobody's going to buy them. So if we want to find the price that maximizes our revenue, that's what this problem is all about, right? We want to find that perfect price that we can charge so that we get the most people possible buying tickets. So we have to go back to our revenue function that we created, which was r of x equals negative 1,000x squared plus 23,500x. And we need to find our maximum value, okay? We need to know that price. And in this case, our price is our x value because that's what we set x to be equal to. We set x to be equal to our ticket price at the beginning of the problem. Remember, our x value is the ticket price. And our r of x, which would be our y value, that is our revenue in this problem. So what we need to know is what is the x value of the vertex. Maximums always occur at the vertex. So I'm going to use the algebraic method. The x is the opposite of b over 2a. So this is negative 23,500 divided by 2 times negative 1,000. You grab your calculator and do the math. And this ends up being $11.75, okay? So the ticket price that's going to yield maximum revenue for this stadium is going to be $11.75. And again, I just want to reiterate that when you get to your homework problems or your bookwork problems for this set, number 27, you want to set up just like this problem, and that should help you get a great head start on that.